Welcome to the next module. In this module, we will be studying about ocean processes sensitive to acidification. So we will focus mainly on many of the inorganic species that are involved. So first, the macronutrients, nitrogen species. The ocean acidification has less effect on inorganic nitrogen species like N2 gas or nitrate ion or nitrite anions. The exception is ammonia. Ocean acidification increases the relative abundance of ammonium ion because ocean acidification leads to release of H plus ion. Those H plus ions are being captured by ammonia that gets converted to ammonium ion, and possible reduction in the air-sea gas exchange of ammonia. So these are all the two changes that is happening. In the case of phosphate speciation, minimal changes in the distribution of phosphate species happens. And in the case of silicate will change only slightly as it is dominated by the SiOH4 species. Ocean acidification and the trace metals. So here the trace metals such as manganese, iron, cobalt, nickel, copper, zinc are essential nutrient for biological functions. They are getting affected. Any change in the available amount may directly change or disturb the distribution of phytoplankton species in ocean and neritic environments. So this is the change that will happen. Cell membrane permeability is also affected by the pH change. Changes in the H plus ion, carbonate anion, hydroxide will directly affect the speciation of inorganic metal complexes, and changes in the H plus and metal plus ions will affect the speciation of metal complexes with the dissolved organic matter. So these are all the changes that will happen. In the case of coastal acidification, we talk about the low-level process. So, the coastal, in the previous module also we talked about there is a difference between the deep ocean and the coastal area. So, here again we are looking at that. So, why the coastal area has a different pH? That's because the freshwater inputs. So, this alters basically the seawater chemistry because there are a lot of fresh water entering into the ocean. So that's the reason it changes the seawater chemistry. And this also freshening of the ocean, that means lot of pure water entering the ocean. And this adds actually the dissolved inorganic carbon, total alkalinity, dissolved and particulate organic carbon, nutrients from riverine and estuarine sources. So all these things are added when the fresh water enters the ocean. There is a greater influence of East Coast and the mid-Atlantic Ocean than the Pacific Coast, especially in the Arctic region. And this actually creates a condition for dissolving calcium carbonate structures. So this is what is the major thing, that is change of pH, that is increase or the acidification of ocean leads to dissolution of calcium carbonate structures. And when we talk about the nutrient inputs, basically the increase in the coastal acidification by enhancing biological respiration, that is one thing that happens because nutrients are more. This actually promotes the phytoplankton bloom. So this is the positive effect of change in or increase in the concentration of carbon dioxide in the ocean. So the phytoplanktons, when they die, they are consumed by bacteria. The bacteria respiration leads to carbon dioxide production, which results in the acidification depending on the local conditions. It may lead to water column stratification or residence time change happens. And when we talk about the climate or the bigger changes, there is a increased glacial melt, and also there is a high intensity precipitation events that are happening, and the increased glacial melt lead to larger freshwater plumes. So when we look at the major ions in the seawater, the chloride ion is a major contributor with 55%, followed by Na plus ion, which is 31%, and the next biggest one is the sulfate anion. So when we talked about the pH with respect to the marine science, people talk about sulfate anion also into the pH calculation. So that is because sulfate is present in large excess in the seawater. The other ions include Mg2 plus ions, Ca2 plus ions and K plus ions. And on an average, what we can say is like around 35 grams of salt is present in each kilogram of seawater. So Foshammer's principle is basically based on this one. So the rule of constant proportion states that even though the absolute salinity of ocean water might differ in different places, the relative proportions of the 6 major ions within the water always remains constant. So this is the Foshammer's principle. So for example, no matter the total alkalinity of seawater sample, 55% of the total salinity will be due to chloride anions and 30% due to sodium and so on. So this is a very constant thing which is happening throughout the world. Since the portion of these major ions does not change, we call this as a conservative ion. So this is the most important term you have to remember. And what are the conservative ions that are present? Basically chloride, sodium, sulfate, magnesium, calcium and potassium are the 6 major ions. And of course, according to Dittmar's principle, bromide ion is also included, so which is the 7th one in the rule of constant proportion.